we now have to, we can look at inequalities, and under inequalities there, we need to know what an inequality is. An inequality contains any of the following symbols. It contains less than, this one is less than, this one is greater than, less than or equal, greater than or equal. So it contains one of those symbols. Instead of having an equal sign, it bears those symbols: less than, greater than, less than or equal to, greater than or equal to. An equation, an expression having such is known as an inequality. And there are some things that you can do with inequalities. You see that this one is true. 3 is less than 6. That is truth. Indeed, 3 is less than 6. Now, the first note we have there is that when you add or subtract a positive or negative number on both sides of the inequality, it does not alter, it does not change the inequality. Let us do this. Let us subtract a 3. Subtract 3 from both sides. 3 minus 3 is less than 6 minus 3. 0 is less than 3. It is still holding. We have subtracted the 3 from both sides. Let us add 1 on both sides. Let us use this. Add 1. 0 plus 1 is less than 3 plus 1. 0 plus 1 is 1, is less than, what is 3 plus 1? That is 4. 1 is less than 4. That one is still correct. So by adding a positive integer on both sides of the inequality, you have not changed the inequality. That one is true when you subtract, when you add all numbers, or whether positive or negative, addition and subtraction. It can work like that. However, let us get this. With the same, let us consider this one is also a fact. 8 is greater than 5. That is reality. Let us try to multiply through by 3. If I multiply 8, I have 8. 3 times 8 is greater than 5 times 3. That is multiplying 3 on both sides. 24 is greater than holding. So multiplying by a positive will make the thing still to hold. Let us divide by 2. 8 is greater than 5. Divide by 2. Divide by 2. This one is 4 greater than 2.5. It is still holding. So dividing by positive will render the inequality unchanged. So here we multiplied through by 3 and nothing changed. We divide by 2, which is a positive, nothing. So adding, subtracting and addition, that one is okay for all integers, whether positive or negative. When it comes to division, it is okay for positive numbers. When it comes to multiplication, it is okay for positive numbers. Let us look at one other case, number 3, which is talking about dividing by a negative. This one is supposed to be negative. That word there, shall change that to negative. What changes the inequality is multiplying by negative. However, if you divide or multiply both sides of the inequality by a negative number, the inequality changes. Negative, the one which changes the number. So let us have this. 2 is less than 3. That is truth. Let us have this. 2 divided by negative 1 is less than 3 divided by negative 1. We are dividing through by negative 1. 2 divided by negative 1 is equal to negative 2, less than 3 divided by negative 1 is negative 3. That one is now not okay, because according to the number line, whatever is on the right is greater than whatever is on the left. So this is negative 1, negative 2, negative 3, negative 4. You see that negative 3 is here, negative 2 is there. So negative 2 is greater than that, because the greater values are on the right. You cannot have 2 on the right of negative 3 and you say that negative 3 is greater than negative 2. So this one is now not correct. That one is not correct. It would be correct if we did this. Negative, we have 2 less than 3. And when we are supposed to divide by negative 1, we would say that now this one is 2 over negative 1 greater than 3 over negative 1. In which case we shall have that negative 2 is greater than negative 3. So we are saying that if you divide or multiply both sides of the inequality by a negative number, the inequality changes. That is the reality. So when it comes to a point where you need to divide by a negative number, you have got to change the inequality. That is what we are going to do. Each example will have its own requirements. And when a requirement comes that you are supposed to divide by a negative number or multiply by a negative number, you have got to change the inequality accordingly. So we have the first example. We have that says solve the following inequalities and check the solution set. 2x plus 6 is less than 2. 2x plus 6 is less than 2. Let's take that one that side. 2x is less than 2 minus 6. You handle when it comes to numbers crossing the inequality sign, they behave as if they are crossing an equal sign. That what was positive on the left hand side of the inequality becomes negative on the right hand side. That's why the negative is there on the 6. So we have that we have 2x is less than negative 4. Then we shall divide through by 2. So this is 2x over 2 less than negative 4 over 2. This is not dividing by negative, we are just dividing by 2. So we have that x is less than negative 2. X is less than negative 2. They said we should check the solution set, and the solution set is equal to, the solution set is a set of x such that x is less than negative 2. That's how we can write the solution set. X such that these things are read as such that you have two. It's like a 2 dots, one up and one down, semicolon or colon. So we have they said we should check the solution set, and let us use it for x. Take any number which is less than negative 2. Shall take negative 5. That negative 5 is less than negative 2. So get any number less than negative 2 and you substitute it in the original equation, in the original inequality. Substitute it there and see whether it checks. So you have 2 times negative 5 plus 6 is less than 2. 2 times negative 5 is negative 10. Now plus 6 is less than 2. Negative 10 plus 6 is negative 4, less than 2. This one checks. Which checks? That one is checking. It is correct. So that is example 1. The second one is we have 1 minus x less or equal to negative 1. Let this one move to that side and that x remain there. So we have negative x less or equal to negative 1 minus 1. Negative x less or equal to negative 2. And around here to remain with x alone, we want to get the value of x. So we want to have negative x divided by negative 1, and now you are dividing by negative 1. Immediately we should change the inequality from rule number 3, from the note number 3. So divide by negative and change the inequality from less than to greater than. If it was greater than, we could change it to less than. So this one is x greater or equal to 2. So that's what we have, x greater than 2. You check with the x equal to, let us check with x equal to 5. In a number greater than 2, you can take a 5. So we have that 1 minus x, not 1 minus x, 1 minus 5 is less or equal to negative 1. What is 1 minus 5? That is negative 4, is less or equal to negative 1. So for this less or equal, provided one of them is satisfied, the inequality is valid. So this inequality is valid because negative 4 is less than negative 1. So it is a valid inequality. So this one checks. Which checks? It checks. That is what we have there. Then this one here, example 3, is saying that x minus 2 over 7 is greater than 1. Now for this one, which is a fraction, we normally have to multiply by the LCM of the denominator. So now here we have only 7 there, so we can say multiply through by 7, and we have x minus 2 over 7 times 7 greater than 1 times 7. So that this 7 will go with that 7, and I remain with x minus 2 greater than 7. X is greater than 7 plus 2, and I finally have x greater than 9. That is the inequality. Now to check, use x equal to 10, because x equal to 10 is greater than 9. So let us test with x equal to 10. We have that 10 minus 2 over 7 is greater than 1. 10 minus 2 is 8 over 7 greater than 1. This is one whole number, 1 over 7 greater than 1, which checks. This one checks. Yes, because one whole number and 1 over 7. This one is greater than that by 1 point, by 1 over 7. This is just a 1. So that one is correct. X greater than 9. Then we have this one is 3x 3x over 16 is less or equal to, let us write this one as an improper fraction. It is 9 over 4. 9 over 4. And after that, let us multiply through by 16. So we have 16 is the LCM of the denominators. This one is 16 and this is 4. So you have 16. So you have 3x divided by 16 times 16 is less or equal to 9 over 4 times 16. When you have that, you are trying to remove the fractions and remaining with only whole numbers. This one goes with that, and on the left hand side we remain with 3x less or equal to, on the right hand side, by 4 1, by 4 4, then 4 times 9, that one is 36, and then from there the value of x alone, the solution set, we have 3x divided by 3 is less or equal to 36 divided by 3, such that x is less or equal to 36 over 3, that one is 12. So x is less or equal to 12. Let us check with the test with the x equal to 10, because 10 is less than 12. So let us have 3, this one is 3 times 10 over 16 is less or equal to 9 over 4, 2.25, and this one is 30 divided by 16 is less or equal to 2.25, and indeed 30 divided by this, because even if this one was 15 here it would be 2, but it is 16. So this one here, 30 over 16, is less than that. So this one checks, which checks it is okay. Then we have this one here, e, x over 2 minus x over 2 minus x over 4 greater than negative 2. Now here you have that you can see 2 and 4. The LCM is 4. There is a factor. So when you want to get the LCM there, it is 4. You know how to get LCM. Check the videos on this channel. There are those which can teach you how to get the LCM. LCM is 4. Multiply through by 4. When I say multiply through by 4, it means that you multiply here and there and there. Multiply every term by 4. So we have x over 2 times 4 minus x over 4 times 4 greater than negative 2 times 4. Every term by 4. Now by 2, 1 by 2, 2. That one is 2x minus by 2, 1 by 2, 2. So this one simply x is greater than negative 2 times 4. That's negative 8. So 2x minus x, that one is x greater than negative 8. And that one is simply that. So we have that x greater than negative 8. Shall check with x, anything greater than a negative 8. Check with x equal to 0. That one is greater than, it is greater than negative 8. So when x is 0, we have that, let me write this side. Oh, snaps. This one is, I'm substituting there. Actually, to check, you substitute the value which you assume here, substitute it there. Why are we using 0? We are looking for a value which is greater than negative 8. 0 is greater than negative 8. So it is far greater. 8 steps, I think. So we have 0 over 2 minus 0 over 4 is greater than negative 2. 0 over 2 is 0. Minus 0 over 4, 0 minus 0 is 0. So 0 greater than negative 2. And this one checks. Which checks? 0 is indeed greater than negative 2. So it checks. That's what you have there. Then this one, last of this example, we have that x over 3 plus 5 over 6 is less or equal to, shall write this one as 3 over 2. 1 and a half, 2 times 1, 2, plus 1, 3. So it is 3 over 2. We shall multiply through by 6, because 6 is the LCM there. So multiply through by 6. So this is x over 3 times 6 plus 5 over 6 times 6 less or equal to 3 over 2 times 6. That's what we call multiplying through by 6. You multiply every term by 6. Now by 3, 1 by 3, 2. So you are having a 2x from this point. That is 2x plus this 6 will go, remain with the 5 alone, less or equal to, by 2, 1 by 2, 3, then 3 times 3, that one is 9. Then 2x is less or equal to 9 minus 5. Actually this 5 will move to that direction. It is going on it is being moved to the right, crossing the inequality sign and becoming negative. I told you, treat that inequality, treat the inequality sign like an equal sign, but don't write equal sign. You should write it as an inequality. But when it comes to having a term cross that inequality, you treat that term as if that term is crossing an equal sign. And now we have 2x is less or equal to, that is 4. And I have 2x over 4 less or equal to 4 over 4. It is not over 4. It's supposed to be over 2. So we have 2x over 2 over 2. This one is a positive number, so nothing happens to the inequality. 2x by 2, that one is x, less or equal to 2. So we are having that x is less or equal to 2. Let us take something less than 2, preferably 1. If I take less than 2, let me take a 0. It is easy to use a 0 here, because 0 is less than 2. Use x equal to 0. So when x is 0, I have 0 over 3 plus 5 over 6 less or equal to 1 and a half. And indeed, this is 0. 5 over 6 is less than 3 over 2. This one is far less than that. This one is x, it is above 1. This one is between 0 and 1. This one here is 5 over 6. Yeah, my writing was not fine there. Maybe let me write it properly. 5 over 6. 5 over 6 is less or equal to 3 over 2, which checks. So we shall have that question 2. We are going to start from it, to start from there in our next video. Just watch all these videos, they are here. This channel contains all of them. Just look for it, it's going to be there. Peace. Example 2 is saying that solve the inequalities and check the solution sets. Now we have 12 plus d minus 3 greater than 11. We shall open the brackets there. There is nothing special, but they put it in the brackets. 12 plus d minus 3 greater than 11. Let us remain with the d alone on the left hand side. So we take the rest to the right. So d is greater than 11. d3 crossing the equal sign becomes plus, so that is plus 3. Then 12 becomes a minus the other side. So I subtract 12, and when I work out this, I get that D is greater than, this one is supposed to be a 2, because 11 plus 13, that is 14, minus 12, that is 2. So D is greater than 2. Let us do this. Check. Use D equal to 3. That is a number greater than 2. Remember they say D is greater than 2. So use a number which is greater than 2. So we have that 12 plus 3 minus 3 is greater than 11. This one and that one goes, so 12 is greater than 11. This one checks. Which checks? That one is correct. That is, we have checked the inequality, and we are saying that it is matching, because we have got that when we get D greater or equal to 3, a number which is greater than 2, somebody may say, now where is this person getting the, like, where are you getting the 3? They said D is greater than 3. So get any number greater than 3. You can even check using 10, 100, provided it is greater than 3. You can even check with 100 here, because here this is 12 plus 100 minus 3. That one is 97. Now 97 plus 12, you get the answer there. And that answer you are getting is greater than 11. And it still checks. So you can check with any number, but you use a same number. Don't overdo it, please. Get a number which you can easily solve and get the answer. Part B, 5 into 2 minus h plus 9h is greater than 0. Let us open the brackets. 5 times 2, that one is 10, minus 5 times h, that one is 5h, then plus 9h greater than 0. Let us take this 10 to that side. Now negative 5h plus 9h to get us 4h is greater than negative 10, because the 10 has crossed the inequality sign. To get it should become a negative. Now 4h divided by 4 is greater than negative 10 over 4. That is dividing through by negative 4. So we have that h is h is greater than, I'm behaving like one of some of the students. They remove the inequality sign and they continue writing equal sign, equal sign. Please resist that as much as you can. Don't use when you are given an inequality. Don't write equal sign is there. You are going to fail those things. So hold the inequality the way it is there in the question. So though you are having them cross line and changing the sign is like it's an equal sign, but you hold that inequality sign, because that one will be an inequality. It is not an equal. It's not an equation. Don't make it an equation. So this one is that h is greater than 2.5. So we shall say check with any number greater than negative 2.5. Let us check with h equal to, let us use negative 3, because negative, not negative 3, please. Let us check with h equal to 0. I prefer using this 0, because 0 is greater than negative 2.5. So we can use it. It simplifies work somehow. So I have 5 into 2 minus 0 plus 9 times 0 is greater than 0. Now when I work out this, 2 minus 0 is 2. So 5 times 2, that is 10, plus 0 is greater than 0. 10 is greater than 0. This one is correct. Isn't 10 greater than 0? Yes, it is. So this one which checks, this one checks. You have got that. Then this one is another example. Oh, this one, man, is so what we are going to do, 2 over 3w plus 1 over 2 is greater or equal to 1 over 2w plus 1 over 3. It is sometimes daunting to use this term here. Sometimes daunting to use this fraction is, so what I normally do, multiply through by the LCM. You will have got away with the fraction thing, which are, yeah, they are scary. So multiply through by 6, because precisely 6 is the LCM of all the elements in the denominator. 3, you have 3, 2, 2, 3. So 6 can work out because it is the LCM of everything. So what we are going to do, these are 4 terms, 1, 2, 3, 4. Multiply through by 6. Each term should be multiplied. 2 over 3 w times 6 plus 1 over 2 times 6 greater or equal 1 over 2w times 6 plus 1 over 3 times 6. That is what we call multiplying through by 6. You multiply each term by 6. By 3, 1 by 3, 2. So there is a 2 which remains here. 2 times 2w, that one is now 4. I get 4w plus this one is 3. Half of 6 is 3. Greater or equal to, this is w, and there is a 3 which comes from a half of w. Half of 6 is 3. So this one is 3 w plus a third of 6 is 2. And what we shall have, let us take this 3w to the left and have this 3 come to the right. And when we do that, we shall have that 4w minus 3w is greater or equal to 2 minus 3. 4w minus w, that one is w greater or equal to -1. And that is what we have there. It is the final thing. Now let us check with greater than -1. Yes. So you take w equal to 0. 0 is greater than -1. I told you I can easily use 0 because it is easy to use a 0. It has many things cancelling out. Like if w is 0, why are we using 0? We are choosing any number which is greater than -1. So it doesn't matter which number you use, provided it can favor your calculations. If you can calculate properly using whatever number you're going to select, please select that. If you think 100 is okay for you, you use w equal to 100 and substitute there 2 over 3 times 100, 2 over 3, 2 over 3 times 100 plus a half greater than or equal to 1 over 2 times 100 plus a third, and see whether the equation checks, whether inequality checks. I prefer to use this simple thing. I have 2 over 3 times 0 in the place of w plus a half greater or equal to a half times 0 plus 1 over 3. And this one is now 0. That one will get us a 0. So I remain with a half on the left hand side greater or equal to, this one is another 0, that is a third. And indeed, one of the two, it is greater than or equal to. So one of the two conditions is satisfied. Once one of them is satisfied, like the greater than is being satisfied there, so that equation is holding. So we say this one which holds, which checks, it is correct that a half is greater than a third. So the value we have got, this solution set, the value of, actually the solution set here is that Sometimes they want you to write, and they say solve and write the solution set or represent the solution set on a number line. But if it's just about writing it, solution set is equal to, the solution set here is a set of W such that W is greater or equal to -1. That's how we write a solution set. We write it like that. Solution set equal to, you have the curly brackets and say W such that, we read this one as such that W such that W is greater than or equal to -1. That has been another example. Can move on to part D. Yeah, things are getting tough and tough, but not becoming undoable. They are still doable. So we have right now we have 3/4. When we put something in brackets, it is like getting that thing and making it into a bundle. So when you are handling terms, you one term. So you have this one and then that part there and then this other one. So what we are going to do is to multiply through. We can continue with our business of multiplying through to get rid of the fractions. 4 and 6, the LCM is 12. So we are going to say 3/4 times 12 minus 2 minus 3x times 12. That is another block. The whole bracket together, they are multiplying it by 12. Then less or equal, it is less than 1/6 into x plus 1 still times 12. When I multiply by 12 here, by 4, 1 by 4, 3. So 3 times 3, I get 9 minus, around here we are going to open the brackets because this 12 is affecting each of the numbers here. So I have 12, maybe I can say minus 12 into 2 minus 3x is less than 12. Here will render this thing to be a 2 into x plus 1, and upon doing that I have got rid of the fractions. Now I multiply through by 12. I just need to open the brackets now. I have 9 minus -12 times 2, that is 24. Then -12, there is a negative and a negative. So this one is plus, that is plus 36x less, or it is just less. Then you have 2x plus 2. 2 times x, 2 times 1. So you have 2x plus 2. And then we shall have 36x minus 2x is less than the 2 there, minus 9 plus 20, 24. That's what we are going to do. We shall multiply. Let the 9 will cross the inequality sign, gets a negative on the right hand side. The 24 was negative here, it becomes positive upon crossing the inequality sign. 2x was positive here, becomes negative on the left hand side upon crossing the inequality sign. This one is now 34x less or equal to, I don't know why I'm putting less or equal to, it's just less than. Now this one is, we have, it is like a 26 minus 9, which will get us, it's something like a 17. That one is 17. Then we have 34x divided by 34 is less than 17 divided by 34, and x is less than I think that one is 1/2, because by 17 1, by 17 2. X is less than a half. Now x is less than a half. Still I want to use a 0 to check the thing, because 0 is less than a half. So we have that x, for x equal to 0, we have 3/4 minus 2 minus 0, because 0 there, when we put a 0 there, we have 3 times 0, which is 0. So that's why I'm having 2 minus 0. It is less than 1/6 into 0 plus 1. Now this one is 2 minus 0, it is just a 2. So when I have 3/4 minus 2 less, this is simply 1/6, because 0 plus 1 is 1, and 1 times 1/6 is 1/6. What you are going to get here is negative. It is negative, and because it is a negative, there is no way that negative can be greater than 6. So this one is, it checks. This one checks. This one is going to get us negative 5 divided by 2 less than, this is 5 divided by 4. It is less than 1/6. You see, negative 5/4 less than 6, and this one checks, because that is true. When are we writing that this one is checks? Why are we saying which checks? We shall say that it checks when you have that the inequality you get here is correct. If you work out something and you get that maybe, for example, somewhere out there you get 6 greater than 9, then you say which doesn't check, because this one doesn't check. 6 is not greater than 9. So when you get 6 less than 9, you say which checks. When you get this one, then you know there is a problem somewhere, that it has not checked. That one has been number 2. Shall move on to, shall get another example. Peace. Question 3. Solve the inequalities and check the solution set. We are still continuing with the solutions of inequalities. Now we shall have this is 1 minus x less than 2. Let this one get to the right hand side of the inequality, and the left hand side remain with negative x less than 2 minus 1. The one has crossed the inequality sign and it becomes a negative. So now we have negative x is less than 2 minus 1, which is 1. Now at this spot, we are going to divide through, because we are supposed to get the value of x, not the value of negative x. So to get x alone, we are going to need to divide through by negative 1. If I divide here by negative 1, I shall get x, because negative x divided by negative 1, I get x. And now right here, I shall have to change this inequality in line with the rule, because the moment you divide by a negative number, by a negative expression, you have got to change the inequality. If it was less than, it goes to greater than. If it was greater than, it becomes less than. If it was less or equal, greater or equal, it becomes greater or equal. If it was greater than or equal, it becomes less than or equal. So this one is now 1 divided by negative 1, and at the end of it you have x greater than negative 1. And to ensure that this one is correct, and they said check the solution sets. So the solution set is this one is the solution set. Solution set is the set of x such that x is greater than negative 1. That is the solution set. Now let us take any number greater than negative 1. Take x equal to 0. I told you I prefer 0 because it simplifies the work. Whatever things can easily cancel out. So when I get this x equal to 0, I substitute it in the original expression and see whether this inequality, and I see whether this solution satisfies that inequality there. So when I take x equal to 0, why x equal to 0? Because we are looking for a value which is greater than negative 1. You can get any other value, but I decided to use 0. You can use your own. So I can put a 0 there. 1 minus 0 is less than 2, implying that 1 is less than 2. This one checks, I guess, because this is correct, which checks. Let's see what we have there. Five minus x greater than 0. Let's take the 5 to the right hand side. Negative x is greater than 0 minus 5. Negative x is greater than negative 5, such that now negative x divided by negative 1 is less than negative 5 divided by negative 1. I'm changing the inequality because I'm dividing by a negative number. So x is less than negative 5. We can take any number which is consider any number less than negative 5 and see whether it can satisfy that inequality. Shall also take any number less than negative 5. Take x equal to negative 6, for example. Negative 6 is less than negative 5. So when I put it there, I have 5 minus negative 6 in the place of x is greater than 0. 5 minus negative 6, that one is 11 greater than 0. And this one checks, which checks. That's another thing. But see 2x, let us open the brackets. 2 into x plus 3 is greater than or equal to 5 into x minus 3. So let us open the brackets. 2, let me first write this equation, this inequality, greater than or equal to 5 into x minus 3. Open the bracket. 2 times x, that is 2x, plus 2 times 3, that one is 6, greater than or equal to 5 times x, that is 5x. 5 times 3, it is a minus here, so that is minus 15. And then let us correct the like terms together. So we have 2x minus 5x is greater or equal to negative 15 minus 6. When I get 2x minus 5x, I get minus 3x greater or equal. This one is greater than or equal to. Now negative 15 minus 6, that is negative 21. And to get x alone, we shall get negative 3x divided by negative 3. It is now less or equal to negative 21 divided by negative 3. At the moment of changing the inequality, at the moment of dividing by the negative is when you change the inequality. The moment you divide by negative, that step should have the inequality changed. Because if it doesn't change from here, this part will be making no sense. Don't just change the final answer, change from that spot there. Now here we have x on the left hand side is less or equal to, this one is now 7. You we shall check with x equal to 0. Isn't 0 less than 7? It is. So we can check with it. So we have 2 into 0 plus 3 greater or equal to 5 into 0 minus 3. 2, 0 plus 3, that is 3. Then that one is 6 greater than or equal to, this one is 5 into negative 3. 6 is greater than or equal to negative 15. This one checks because that is really true. That 6 is greater than or equal to negative 15. I told you when it is an inequality, if it is greater or equal, the moment one of the condition is satisfied, the inequality is rendered correct. So this one is satisfied, the greater than is satisfying the inequality. So it is a correct inequality. So this solution is set here. This solution is correct because we got x less than is x equal to 0, a value which is less than 7, and it is giving us something meaningful. Part D, let us open the brackets. 1 minus 7x, this minus 7 times x, then this is a minus and this one is always a plus. So we shall have minus 7, because the 7 is negative and this one is a plus 1, shall have a minus 7, less or equal to 9x plus 10. And let us correct like terms. Negative 7x minus 9x is less or equal to, this one is 10. On the right hand side we have 10 plus 7. This 7 has caused the equal sign go, that become positive. Then this one will go to that side and become a minus. When I work out to the left hand side, I have negative 16x less or equal to, this one is 17 minus 1, that one is 16. So I shall have negative 16x divided by negative 16 is greater than or equal to 16 divided by negative 16. I told you the moment you divide by a negative number, it is not, I'm not just changing the inequality, I'm changing it because I'm dividing by negative 16. So from there, shall have that negative 16x divided by 16, I get x is greater than or equal to negative 1. So I'm looking at a value of x greater than negative 1. And now here we have greater than negative 1. 0 is greater than negative 1. So I'm going to use it still. Don't mind. Use x equal to 0 to check. 1 minus 7 into 0 plus 1 is less than 9 times 0 plus 10. Now this is 1 minus 7. This one times plus that is 1. So this is 1 minus 7 less or equal to 9 times 0 is 0 plus 10, that is 10. 1 minus 7 is negative 6 less or equal to 10. This one checks. Which checks. Negative 6 is less than 10. And it is indeed correct. There we are. One over 6. Let us see what can we do here. We shall have, let us first open the brackets. Shall first open the brackets, but I'm just writing the inequality first. So actually there is 6 here and there is that one there. So what we are going to do first, let us multiply through by 6. 6 is the LCM of the denominator things. We have 6 here and 3. The denominator has LCM 6. So I have this expression 1 over 6 into x plus 10 times 6 less than 1 over 3x times 6. That is what we call multiplying through by 6. I'm doing that because when I multiply through by 6, I shall be getting rid of the fractional stuff, and I have things which are not fraction. So the 6 here, this 6 here, we will cancel with that 6, and I remain with the x plus 10 on the left hand side. This one is less than, now by 3, 1 by 3, 2. So this is less than 2x. That's what I have there. We shall have these 2 move to the left hand side, and I have x minus 2x is less or equal to, it is just less than, is less than, the 10 is now also moving to the right hand side, crossing it, becoming a negative. X minus 2x, that is minus x, is less than negative 10. To get x alone, I need to get negative x divided by negative 1. The inequality is less than, I change it to greater than. I told you if it is less than, it must change to greater than the moment you divide by negative. And this one is negative 10 divided by negative 1, such that x is greater than 10. Now to check this, I am going to use a value of x greater than 10. I'm going to use let me use 14. X equal to 14. I want to use 14. In that case, I shall have 1 over 6 into 14 plus 10 is less or equal to 1 over 3. That is no longer x, but we are saying it is 14. This one and that one is 24. 1 over 6 times 24. Let me do like this. I have 1 over 6 times 24 is less or equal to 14 over 3. 24 divided by 6, we get 4. 24 divided by 6, that is 4, less or equal to. Now this one here is, if I try to work out with this, I'm going to get 4 and then 2 over 3. So this one is just 4 and this one has 4 and some 2 over 3. That means that this side is less than that side. So this one checks. It checks. 4 is less than 4.6666. What you are going to get when you get 14 over 3. So this one checks. And so it means that the solution we have got here is fine. It is checking. Then part F, we have x plus 2 over 9 is less or equal to x plus 2. What we are going to do here, we are going to multiply through by 9. So we have x plus 2 over 9 times 9, that is left hand side multiplied by 9, less or equal to x plus 2 times 9, that is now right hand side also multiplied by 9. When I multiply by 9 here, this 9 will go with that 9. The left hand side shall remain with x plus 2 less or equal to, now this 9 is going to multiply each of these terms. So I have 9 times x, 9x, 9 times 2, 18. And then I have this 9 move to the left hand side, and then the 2 move to the right hand side. So I have x minus 9x less or equal to 18. This one is 18 minus 18 minus 2, such that negative 8x is less or equal to 16. This one is getting us 16. And from there, to get x alone, we shall divide it through by negative 8. So negative 8x divided by negative 8 is greater than or equal to 16 divided by negative 8. We are still changing here because this was less than and we are dividing through by negative. So is greater than or equal to, this is negative 2. Look at any number, look at a number greater than negative 2. 0. X equal to 0. I'm not saying that you should always check with x equal to 0, but if it is okay, you can use it, provided, like here you are saying that the solution is saying that x is greater than negative 2, and the 0 I'm using there is greater than negative 2, so it can be used there for this particular case. So for x equal to 0, I'm now substituting 0 in this original expression. So I have 0 plus 2 divided by 9 is less or equal to 0 plus 2. And it means that 0 plus 2 is 2 over 9 is less or equal to 2. And this one is 0.222 less or equal to 2. This one checks because we can see that this one is a proper fraction. So it checks all the proper fractions are even less than 1, and the other side is 2. So it checks there. Then we have part G. Part G is, let me rewrite it, x minus 1 over 3 into x minus 6 less than 2x. What we are going to do, we shall multiply through by 3 because it is only that 3 which is out there. Multiply every term of the expression by 3. So we shall have x times 3 minus a third into, now the term in bracket is, it is one block, so we shall multiply that block also by what? By 3. It is less than 2x times 3. Multiplying through by 3. And when you do that, you shall have x times 3. That one is 3x minus, this 3 is going to cancel with that 3, and what we shall remain with is just the bracket x minus 6, and the whole thing is now less than 6x, because 2x times 3 is 6x. Let us open the brackets there. This one is 3x minus x, a minus and a minus will render that one positive, minus 6x. Oh, it's less than 6x. Let us take the x's to the left hand side. So this 6x, let it move, go there, and then that one go there. That pointing there is not something to be done in exams. For me, I'm just showing you that for the sake of this tutorial, you know that. So this one is now 3x minus x minus 6x is less than negative 6. The 6 has crossed the equal sign is become the not the equal sign but the inequality sign, and it is now negative 6. The 6x has also crossed the inequality sign, becoming negative 6x. When I work out the left hand side, I have 3x minus x, that one is 2x. Then 2x minus 6x, I get, this one is getting us negative 4x. And negative 4x less or equal to, not less or equal to, man, that is less than 6. After which we have negative 4x divided by negative 4. Inequality was less than, and I'm dividing by negative, it becomes greater than, such that x itself is greater than 6 over 4. X greater than 6 over 4 is the same as 3 over 2, which is 1.5. So it's greater than 1.5. So since it is greater than 1.5, this time they have caught me. I cannot use a 0 because 0 is less than that, and this one is greater than 1.5. So I shall use x equal to 2 this time around. So when I use that, I have that x, which is 2 minus 1 over 3 into 2 minus 6 is less than 2 times 2. 2 minus 1 over 3, this one is 2 minus 6, that is negative 4, less than 4. This one is 4, it is less than 4. And then 2 minus, I have a minus and a minus here, so I shall have this one as some bit of a plus. So I have that this one is 2 plus a third of negative 4 is 4 over 3, less than 4. And this one, when I get this one plus that, I shall have it is 2, actually it is 3 whole numbers, 3 and a third, 3 whole numbers and a third, because that one is supposed to get us, it is 10 over 3, and that one is less than 4, which is correct because this one is 3 and a third and the other one is 4. So 3 and a third is less than 4, which checks. Yeah, that's how we can handle those inequalities. We shall look at this exercise, this solution 4 in the next video. Just keep posted. Thank you for watching. Please subscribe and keep studying. Peace.